In this video, we are going to learn ordinal logistic regression. Ordinal logistic regression is known as proportional odds logistic regression. It's suitable to analyze ordinal categorical outcome variable. In binary logistic regression, outcome has only two categories, for example, deceased versus being alive. In ordinal categorical variable, your outcome variable have more than two categories, which has order in it, for example, disease severity, mild, moderate, severe. And today's motivating example is from a paper published in New England Journal of Medicine, assessing effect of intensity of oral anticoagulation on stroke severity in AFib patient. An outcome variable they use in this analysis is a stroke severity, and which originally was quantified using 5-category scale: no defect, minor stroke, major stroke, and severe stroke, and death in hospital due to stroke. And what they did is they categorized these 5-level data into 3 levels. A minor category combine no deficit and minor stroke. A moderate category is from major stroke itself. And severe category combine severe stroke and death in hospital. An exposure of interest is INR lower than 2.0 compared to INR being 2 or greater. And they use proportional odds logistic regression and computed odds ratio for association between INR and stroke severity is 1.9. And 95% confidence interval does not include 1. Therefore, they found statistical association and concluded lower INR increase odds of having severe form of stroke. And when people hear this result, they may wonder, odds ratio of what? Because we have 3 categories. When you have only 2 categories, such as death and being alive, and you may think odds of dying is increased by 1.9-fold. Although here we have 3 categories. So first question people usually ask is odds ratio of what? So what does odds ratio equal 1.9 means? So let's start with 2x3 table. You have 2 categories for exposure and 3 categories for outcome variable. There are 18 patients in whose INR is less than 2.0 and had a severe form of stroke. And there are 51 patients whose INR is less than 2.0 had a moderate stroke. And similarly, there are 48 patients and INR is less than 2 and had minor stroke. So, as you see, we have 3 categories for outcome. Therefore, we can directly compute ratio for these 3 categories. So in order to compute ratio, you first need to collapse this category into 2 categories. So therefore, you draw 2x2 table and you collapse into 2 categories. So in this example, what we do is we collapse moderate and severe category. So now you have 18 plus 51 and 69 patients and whose INR is less than 2.0 and had either severe or moderate stroke. And now we have familiar 2x2 table, so you can compute odds ratio. And odds ratio for this 2x2 table is 1.85 and p-value is 0.042. Analysis does not end here. We continue to examine next cutoff. And how about if we cut here? And so you will construct 2x2 table using another cutoff. So you combine moderate and minor stroke and put it in one category. And odds ratio based on this 2x2 table is 3.04 and p-value is 0.047. Okay? And instead of showing these 2 odds ratios separately, because it's confusing and you say odds ratio is 1.8, then if you have cutoff between minor and moderate, by the way, an odds ratio becomes 3.04, and if you use a cutoff between moderate and severe. So to make story simple, And why don't we take average between two odds ratio? It's not exactly the average because they do use more complicating formula to pull these two odds ratio. Anyway, pulled odds ratio is now 2.05 and p-value is 0.019 because this analysis and you have more granular data. Okay, so you have greater power to show statistical difference. Proportional odds model is a form of regression, therefore you can adjust for other covariates. So they included age and sex and heart failure and coronary heart disease, diabetes and hypertension and prior ischemic stroke. And after controlling for those variables, found odds ratio of lower INR on severe form of stroke is 1.9. Okay, and what author did is they explained that in the footnote. And because not many people actually do understand odds ratio based on more than two category data. So this is what they said. Estimates of effect are calculated with the use of proportional odds logistic regression models. These models compared severe plus major stroke with minor strokes and also compared severe stroke with major plus minor strokes. So they verbally explain what we just saw in this slide. Let's read what they say in the statistics section. We used proportional odds, ordinal logistic regression models that allowed us to compare multiple outcome categories in order to assess the independent effect of antithrombotic treatment on the severity of stroke at hospital discharge. Okay? And they further say the proportional odds assumptions were met for these regression models. So they say they checked assumption. So when we use linear regression, we did check assumption of residual normality. And this model, we don't worry about residuals, although we do worry about assumption of proportional odds. So what is assumption of proportional odds? So when you say we combine these two odds ratios, some people may wonder, is that really okay to combine these two odds ratios? What if these two odds ratios are meaningfully different? Proportional odds assumptions examine if these two odds ratios are numerically statistically different. Okay, so in SPSS, and we can compute p-value to examine this assumption. Okay? And as you see, the more categories you have, and you can compute these 2 by 2, right? So every single cutoff you can find, and you can draw a 2 by 2 table. And therefore, more categories you have, and you're more likely to violate this assumption. Some people might have wondered why they didn't utilize original 5 category data and why they have to collapse into 3 category data. And because if they use 5 level outcomes and proportionality of hazard assumptions are actually violated. So 5 level, you have 4 cutoff, and that produce 4 different odds ratio. And statistically, one of the odds ratio was found numerically different from others. Okay, therefore you can't really collapse those 4 odds ratios. And then they collapsed data into fewer categories, and they performed assumption checking. And then in this case, p-value was greater than 0.05. So proportional odds assumption was being met. So another challenge of using proportional odds regression is how we explain odds ratio. So we understand odds ratios are pulled over all odds ratios based on each cutoff. And the way we explain the odds ratio is odds ratio of having more severe form of stroke. So challenge of using proportional odds model is explanation of odds ratio. And even with this challenge, and I highly recommend you to use proportional odds logistic regression over binary logistic regression, because when you have a data and collapsing data lead to loss of information, and loss of information leads to loss of power.